Have you ever wondered how our continents, these massive land masses we call home, came into being? From the dawn of human consciousness, we've been driven by an insatiable curiosity about our surroundings. We've gazed at the stars, plumbed the depths of the seas, and probed the inner workings of our bodies. But perhaps one of the most enduring mysteries has been right beneath our feet, the formation of our continents. Imagine, if you will, the enormity of these land masses. Sprawling deserts, towering mountains, vast forests, and teeming cities all make up the continents we live on. These are not just geographical features. They are the stage upon which the drama of life unfolds. They shape our weather, influence our cultures, and even determine the course of evolutionary history. But how did they come into being? How did we end up with 7 continents instead of 1 or 10? To answer these questions, we turn to a theory that has revolutionized our understanding of the Earth, the theory of plate tectonics. In simple terms, plate tectonics posits that the Earth's crust is made up of several large plates that float on top of the semi-fluid layer of the mantle beneath. These plates are in constant motion, albeit at a glacial pace. Over hundreds of millions of years, the movements of these plates have shaped and reshaped the face of our planet, forming the continents we know today. But this explanation is just the tip of the iceberg. The story of our continents is a tale of fire and ice, of unimaginable forces and timescales that dwarf human history. It's a story that takes us back to the very birth of our planet and forward into its distant future. So, are you ready to embark on a journey to uncover the secrets of the continents? Imagine a time when the Earth was just a hot, spinning ball of molten rock. A time so early in our planet's history that it barely resembles the world we know today. This was the Hadean Eon, the first geological eon of Earth, named after Hades, the ancient Greek god of the underworld. Picture a time when our planet was a fiery furnace, with temperatures too high for any form of life, as we understand it, to survive. The Earth was a turbulent place in its infancy, a swirling mass of magma and rock, bombarded by asteroids and comets. This period of violent upheaval lasted for hundreds of millions of years, but gradually, the surface of our planet began to cool, and a thin crust started to form over the molten exterior. This crust was the very first landmass, the precursor to the continents we know today. As the Earth cooled down further, water vapor began to condense in the atmosphere. This led to the formation of the first oceans, a vast expanse of water that covered the majority of the Earth's surface. The continents, as we understand them now, were still millions of years away. Now let's introduce the concept of supercontinents. These were enormous landmasses that formed as the Earth's crust thickened and solidified. The first of these supercontinents was called Valbara. This colossal landmass existed more than 3 billion years ago, and it was the first step in the formation of the continents we are familiar with today. But Valbara was just the beginning. There were several other supercontinents that formed and broke apart over the course of Earth's history, each one playing a crucial role in shaping the geography of our planet. Now think about this. What could have caused these initial land masses to break apart and form the continents we know today? The answer to this question lies in the fascinating and complex processes of plate tectonics, which we'll explore in the next section of our journey through the formation of continents. How did one massive supercontinent turn into the 7 distinct continents we see today? The breakup of the supercontinents, a story of change and evolution that's as fascinating as it's complex. Let's take a journey back in time around 200 million years ago when our planet looked very different. Picture a single giant landmass, Pangaea, surrounded by a vast ocean. But Pangaea wasn't destined to stay whole forever. The Earth had different plans. Enter the hero, or perhaps the villain of our story, depending on how you view it, plate tectonics. What's that, you ask? Well, plate tectonics is the theory explaining how the Earth's outer shell, or lithosphere, is divided into several large rigid pieces called plates. These plates hold our continents and oceans and are constantly, albeit slowly, moving around on the semi-fluid layer beneath them, known as the asthenosphere. Now back to Pangaea. As these tectonic plates started to move, they caused the supercontinent to crack and fragment. This process, my friends, is known as continental drift. It's a bit like a giant jigsaw puzzle being pulled apart. As the plates drifted away from each other, they carried chunks of the supercontinent with them, forming the continents we know today. But it wasn't a smooth journey. Picture the drama of the plates colliding, pulling apart, or scraping past each other. These interactions led to the creation of mountain ranges, earthquakes, and volcanic eruptions. Quite the spectacle, don't you think? Here's a fun fact. This process of continental drift is still happening today. Yes, you heard right. Our continents are still on the move, albeit at a pace slower than the growth of your fingernails. But over millions of years, these small movements can result in significant changes. Can you envision how different our world map would look if Pangea never broke apart? It's a tantalizing thought, isn't it? But it's the ever-changing nature of our planet that makes it so incredibly fascinating. What if I told you that the continents as we know them are not permanent? That's right. The landmasses we call home are constantly on the move, even if we can't feel it. Now, let's take a moment to ponder on what the future holds for our continents. Every year, continents shift about 1 to 4 inches thanks to plate tectonics. This slow and steady movement has been shaping our world for billions of years. So over time, the map of the Earth will change, with continents sliding around, colliding, and breaking apart like pieces of a giant jigsaw puzzle. Imagine, millions of years from now, the Atlantic Ocean starts to shrink while the Pacific Ocean expands. Africa moves northwards, colliding with Europe, forming towering mountain ranges. Australia migrates north to merge with Asia. This might sound like a plot of a sci-fi movie, but it's a possibility that scientists have been contemplating. Now let's dive a bit deeper into the concept of a future supercontinent. You see, geologists have noticed a pattern in Earth's history. Roughly every 4 to 500 million years, the world's landmasses collide to form a supercontinent, and then they break up, drift apart, only to come together once again. This cycle, known as the supercontinent cycle, has happened at least 3 times already. So what's next? Some geologists predict the formation of the next supercontinent, often referred to as Pangea Proxima, or next Pangea. As the name implies, it's the future version of Pangea, the most recent supercontinent that existed about 300 million years ago. But remember, these are just predictions based on current continental drift rates and geological evidence. The Earth's crust is a dynamic place influenced by many factors, and future events can change its course. It's a captivating mystery that continues to intrigue scientists and geographers alike. So while we won't be around to witness these dramatic changes, it's fascinating to think about how the world might look millions of years from now. Will there come a day when we will witness the birth of a new supercontinent? Indeed, only time will tell. How has the formation and movement of continents affected life on Earth? A riveting question indeed. It's like asking, how has the stage on which the grand play of life unfolds influenced the story itself? And the answer is profoundly. Let's start with climate. The configuration of continents plays a vital role in determining global climate patterns. When continents move, they alter the planet's balance of land and sea, significantly affecting the distribution of solar heat across the planet. For instance, when continents are clustered near the poles, they can trigger ice ages as they reflect more sunlight back into space. Next, let's dive into the oceans. The formation and movement of continents have a direct impact on ocean currents. These currents act as Earth's conveyor belts, distributing heat from the equator towards the poles and vice versa. When continents drift and rearrange themselves, they can disrupt or alter these currents, leading to dramatic shifts in climate and sea levels. Now imagine how these changes in climate and sea levels would affect life. They would create new habitats, destroy others, and force species to adapt, evolve, or face extinction. The breakup of a supercontinent, for example, can lead to the isolation of species, triggering a burst of evolution and the emergence of new species. On the other hand, the formation of land bridges can allow species to spread and colonize new areas. The distribution and diversity of life on Earth, from the tiniest microorganisms to the largest mammals, have been shaped by the ceaseless dance of continents. The continents, in their journey over millions of years, have created and transformed the environments in which life has thrived, evolved, and diversified. So the formation and movement of continents is not just a geological process, it's a key player in the story of life on Earth. It's a tale of survival, adaptation, and evolution written in the rocks beneath our feet. Next time you step outside, take a moment to appreciate the ground beneath your feet and the extraordinary journey it has taken to shape our world as we know it.